Um, it's 1:31, and I'm starting now. And class starts at 1:30, right? All right. So uh, I see that students are not coming on time to class. So we'll see what's going to happen. I have to do something about that. All right. So we're going to continue from last time and going through little details of the language until to the point that we can actually get to serious stuff. The very first thing I want to tell you is that we are going to have a quiz either this week or the next week, based depending on how much material we cover. Do we have anything to do? Do we have enough to do in our quizzes? Our quizzes are fully programming. There are no concepts in it. So I was thinking, as I mentioned, think about it. I asked you to think about it. Do you want the concept questions of the midterm to be spread around? So every like 2 weeks, 10 minutes concept, and pack them together and becomes the concept part of your midterm. So in midterm, you have more time to do your program. Think about that. So the amount of questions are not going to be more. The only thing is that for your programming, you're going to get more time. And the concept questions are going to be spread around the semester. So every 2-3 weeks, we do one concept. So essentially 4 concept tests, and it's going to be based on what we talked about last time. You go through those concepts, and we accumulate those marks. 2 of them will be for midterm. Another 2 will be for your final. So instead of doing one intense thing with concept and programming together. So keep that in mind. I'm going to bring that question up later on. Hopefully you will know if you want to do that or not. So we are going to start with aggregate initialization. We've already talked about that in OOP345 a little bit, but it's just another kind of a highlight of it to tell you actually how these things work. Let me just see if I can go to scene 2, I think. Yep. So the initialization that we have done with for all our variables, now we can do it using the curly brackets. So no more assignment is needed in front of anything. If you want to initialize, you can do it, use the universal notation for it with the curly brackets. So you put a curly bracket in front of any type of thing, you can initialize it. Now, if it's a single variable, you put a single value, A is initialized to 5. Any type of variable that you have, or object, or class, you put an empty curly bracket in front of it, it will be defaulted, whatever its default is. So if it's a pointer, it becomes a null pointer. If it's an integer, it becomes, if it's a primitive value, all its bits going to be set to 0, whatever it is. So if it's a character, you're going to have 8 zeros. If you have an integer, you're going to have 32 zeros in there. If it's an employee, the default constructor with no arguments will be called. So essentially, an empty curly bracket in front of anything sets it to blank. When you join online, please mute yourself so you don't have echo over here. Okay, and let me just bring this to the left again, and I'm going to bring you down over here so I can get your responses over here when needed. Just to make sure that I'm not talking to myself. People at home, you can hear me, right?
Yep.
All right.
Yes, Professor. I can't see the screen, though.
You can't see the screen. All right. Let's try it one more time. Do you see the welcome 345 thingy, or you see blank?
Yes.
Do you see welcome 345? So let's try this again. Do you see my screen now?
Oh, yeah, no, no,
Yes,
it's okay.
it is.
Thank you.
All right, perfect. All right, thank you very much for letting me know. And from now on, when I start talking, if you don't see my screen, let me know. Okay. All right. So as I was saying, to initialize variables, you just put curly brackets in front of it and do whatever you need to add whatever you need to initialize them to those values. In line 5, I'm initializing an integer to a 5. In line 6, I'm defaulting an integer, which means if it's a primitive value, all its bits got to get set to 0, therefore resulting in 0. If I have an array of 40 characters, 40 integers, I put an empty curly bracket in front of it, everything will be set to 0. If you initialize the initialization of arrays with curly brackets and some elements there and the rest left unset, works like C language, which means the rest of them will be set to 0. And that's how it works. Questions? Questions? Nope. All right. All right. Also, now I see that people are here, not everyone, but most of you are here. So please, next time, remember we start at 1:30 sharp. So please be here before that. All right? Next thing. So this what we call an initialization. Okay? Next thing, we have a new type of for loop that we need to know about. A for loop is that's kind of automatic. So say you have an array of few integers. Okay? And you want to go through them and say print them. Okay? What you can do, you can use for, and then in here you say integer, you put something like let's say element reference, okay? And then you write over here A. So what happens is this. Now I'm going to say cout ER. And so what happens over here is this. When you write something, a for loop like this, you're essentially telling to the compiler, I want this reference that I have over here. It could be a variable too, or a reference. It doesn't make any difference. It does make a difference, but I'll explain to you why. So if you say this reference, and this reference is going to be an element reference of A 1 by 1. So it starts, the first body of the loop, ER will be the reference for the first one, the reference for second, third, fourth, fifth, and sixth. And it just goes through the array, 1 by 1. Okay? So if I run the program, okay, you see it goes through it. Oh, sorry. As you see, they both work. Can anybody tell me what's the difference between the two? Line 9 and line 6 based on your C knowledge, C++ knowledge. What do you think is the difference between the two? Line 9 and line 6. Okay, so at any body of the loop, what happens is that at any repetition of the body of the loop, this will happen. Whatever. Right? And then it runs through. For the second one, this will happen when you analyze it every single time, correct? Now, what's the difference between the two? Yes, so the first one, ER becomes a new name for A. For every single one, anything you do to ER happens to the elements of the array. In the second one, for every and each element, a copy constructor is called, because you are doing assignment at the moment of creation using the same thing. Careful. Okay? This is very expensive, and things you do to E is not going to happen to init, nothing's going to happen to A. But this one, it's actually the reference, so be careful. Okay? Again, for every single thing that you're using in C++, translate it in your brain and analyze it. You have the knowledge to break it down into pieces, and you can simply connect the dots. Now, this is one of the places that auto is very, very helpful, which means you can actually do this. Okay? By putting auto over here, because in here it changes to auto. Then automatically it picks up the proper type for auto and makes it an integer. So it's very handy when you are going through. And this not only works on an array, later on we're going to find out that it's going to work on all different types of collections that we have. Because soon we're going to leave the arrays and we're not going to use them anymore, because we have better arrays created in standard template library. We're going to see that. But again, bear that in mind. Is sometimes the type that you have over here is a very complex thing, and you don't want to waste your time rewriting the whole type of the elements of the array. So it's easier just to write an auto over here and get over with it. Okay? So that's the range-based for loop. Now this is CPP. It has nothing to do with it has nothing to do with C language. In C language, you don't have such a thing. Okay. As we go through different parts, I mention what is what. We could have structures. Now talking about compound types. I'm switching to compound types. I want to talk about different types of compound types that we haven't seen in OOP345. I want to go through it over here and explain to you exactly how, what is each and how they work. First one is nameless structures. You can actually, or nameless classes. You can create nameless classes, okay? Take a look at this. I'm creating a class student, okay? And I want the class student to have a first name and a last name. But I want these things to be under a package called name. Now, I could have done this. I could actually create something like this over here, say struct name. And in here, I could have called that name, right? Are we okay with this? So I create a struct called name, and I'm going to call it first and last. And then I say a student has a name. A name has a first and a last. Are we good with this? But imagine that I'm not going to use that name anywhere else, ever. It's something that I'm just making it for a student. So it's a waste of time. I don't want to reinstantiate name anywhere else. Let's assume that. If that is the case, you don't want to waste your time and write that thing like that. You can actually have the whole thing as I had before. So instead of having this, you can create a nameless structure or class, if you want to, a structure in this case. And they say struct because if you make it private, you can't access it, right? So I'll make a structure like this, and I'm going to say structure has a first and last, and only one instance out of this is created. It's called mname. So mname is a nameless. So again, connect the dots. When I have this compound type before a variable, what does it mean? It means mname is of type of this. It doesn't have a name. What it is, what it is. It has a first and it has, so you're going to have mname.first, mname.last. Got it? And you don't need to create a structure for it. Nameless structures and classes and compound types like this exist all over the place. Okay, I'll explain it to you soon. And sometimes actually we create classes that we're not going to ever create another one of it. So it's an easy one to create a nameless one, and we'll get to it. So we understand what nameless structures are, right? Are we okay with that? Nameless structs and classes. Okay. Now for this, I'm going to need to do this. Let me see. 1, 2, 3. 1, 2, 3, 4, 5. Okay. All right. Just want to make sure that I am being recorded. All right. Also, and a tiny bit's going to be coming. That's good enough. All right, so we know that. I'm going to turn the light on so this goes a little brighter. Sorry about that. So this is our memory. No, this is not our memory. This is our memory. Okay? And in this memory, you create some kind of a structure, and that structure, let me just see what example that I put over. Yeah, let's say I want to create an address for someone. Okay? If I want to create an address for someone, this is the space that that address is going to get in memory, right? But I want this address to work for Canadian version and for US version. Now, Canadians use postal code. US uses zip code. So one way is to create this structure and have something like this over here, zip, and have another piece over here for the postal code, right? And then the rest. Okay? But is it possible to use them both at the same time, zip code and a postal code? Is it possible that somebody have an address that has zip and postal code at the same time? Impossible, right? So it would have been nice if I could look at these two pieces of memory in two different ways. A zip code is an integer, right? And that's 4 bytes. A postal code is 6 bytes, 6 characters, right? So what if instead of designing like this, I could actually occupy 6 bytes over here and call it postal code, okay? And then be able to look at the exact same place and looking at it as zip code. Because they're not going to overlap ever. So if I refer to this place as a zip, it's going to look at it as 4 bytes. When I look at it as a postal code, it's going to look at it as 6 bytes. Okay? If I could look at the same piece of memory with different types, as if you look at something with sunglasses, and then now you look at something with no glasses, okay? It is the same place, but you have a different view of it. Are we okay with this? We can do that. We call that a union. So a union is essentially a structure that when you create, every single attribute that you put in it starts from the beginning and overlaps the other one. Which means if you set one of them, the other one's going to get overwritten. But your logic dictates that it's impossible for both of them to be used at the same time. You follow? So it's like that. So in here, instead of, so I could, if I wanted to create an address, so I have over here something like that, whatever. Okay? And then I have union. I'm going to say size, union size tzip and character postal code 6. And I call it code. So if I say code.zip, it is an integer. It is a size t. It's an unsigned integer. When I say code.postal, it's an array of 6 characters. And when I write, but based on the country, I'm going to pick in my logic one of them. It is impossible for both to be used, so I'm safe. And my address becomes smaller. I save at least 4 bytes in there. Are we good with this? Okay, and that's a union. Now, unions can be done for anything you want. So if I actually create something like this, again, this is just an example. So I have 3 different variables. If the variables that I have, I want to only look at it either at a double or an integer or character of 7 bytes, I can create something called vars. But I have to be aware that it's like a radio button. When I push the A, the other 2 are going to get destroyed.
Always
Yes, exactly. They're always an exclusive value. You cannot use 2 of them at the same time. Okay? Unless, you can't. There is no unless. Okay? So if I actually write in double, it's going to write the 8 bytes. It's going to overwrite the 8 bytes. If I write an integer, the first 4 bytes will be overwritten. Obviously, the double is going to get ruined. And if I use the character over here, then the arrays are going to be used depending on what I'm using. So the size of these vars is going to be 8, obviously. And the first 4 bytes is going to be an integer, and yada, yada, yada. Are you okay with this? Are we okay? And that, ladies and gentlemen, is a union. So the main I have written over there was like this to kind of show what's going on. First of all, I'll show you what is the size of vars, what is the alignment of var, and I do a reinterpret cast to unsigned long to see what is the address that the integer is sitting at, the double is sitting at, what is the address that C is sitting at, and we'll go through it. And then if I set one, what happens to the other? I just wrote some code over here, walk through it, and you'll see. So when I actually run this, you'll see that the addresses of the variables are identical, which means A and C are sitting at the same location, which means if you write on one, the other one's going to be overwritten, and the rest of it, walk through it and just see how you access it. It's the syntax for it. Questions? So unions. Next thing, and I don't think I have a code ready for it over here. Yes, go ahead. No. Okay, what is a template from OOP345? Do you remember? So the recording it's on. Okay. So you said, can we use template for this? Let me explain what template is. Let me not just put you out of your misery. So a template is essentially asking the compiler to create a new type based on our demand. You're not reusing the same location of memory. If I have template of a structure and I create it for type int, it creates a type of that structure that is accommodating an integer. And if I create that one with a double, then it creates another structure that accommodates a double. But these two are two separate types. They have nothing to do with each other. They have their own memory location when created. What union does, union says, I'm going to bring everything in the same address, and you can pick one of them so you save some memory. Okay? That's all. Yes?
It's basically as if you were in an assembly line for a car, let's say, depending on the specific model and what the people requested, you can either put something, like for example a spoiler in the back of the car, or you can put some other ornament at the back of the car, or you cannot do, or you don't put it here. Basically, you have like a preset of what you're going to input at that space in particular.
Yes, but the space is common for all of them.
Exactly.
The same, it's going to be assembled at the same location, but what is assembled is a different thing. Yeah, you're absolutely right. I like your implementation of the code.
Well, you see it also very often in computes when they're making it, that they usually leave the ports.
And then you can install different types of things over there. Exactly. So yeah, it comes handy in many places. Okay, yeah, just, yeah. Anyway, so that's union. So in C language, we didn't used to have, actually, let me just tell you this. There's something called enumeration. We can actually enumerate things to make the language more readable and understand how it works. For example, if you want to have weekdays, like you have Sunday, Monday, Tuesday, Wednesday, you're going to have something like that. You have to create some kind of a setting for it. Say I'm going to define Sunday as 0, Monday as 1, Tuesday as, and it keeps going like that up to 6. And so wherever you are using Sunday, the value is 0, so therefore you can actually enforce your logic. There is a tool for this in C language, not C++. C++ made it object-oriented. So what I'm teaching you now, it's C, then I'm going to show you the object-oriented version. It's called enumeration. So I can say enum weekday, for example. And then in here, I'm going to say Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So after doing something like this, if I say cout Wednesday, you will see that. 3 is printed. You see that? 0, 1, 2, 3. Okay? So essentially, now I can actually create something like this. So that becomes actually a type. I can actually say, if it was C, you should have, it's exactly like a structure. You have to say struct weekday to create a variable for it. But for in C++, I can simply say weekday, W, and I'm going to say, I don't know, W is equal to whatever. Yes. Go ahead. Anybody have a question at home? Oh, just, okay. So if I do something like this, now I can say if W is Wednesday, do this and that. So it becomes more readable. You could have done this manually yourself. So you could simply say integer weekday, integer W, and then put those set constant values like that and use it yourself. But if you didn't want to do that, this is created for you and makes your life easier and makes your program more readable. You can use switch for it. You can use switch for it, obviously. You can use switch for it, but so yeah, you can use.
So the first one is C++, and
No. Everything over here is C. Yeah, the only thing that is C++ is C out. I mean that enum, you can do it in C too. Okay? Enum, but Sunday, Monday, Tuesday, these are global file scope constants, which means you cannot use WED anywhere in your program anywhere because it's a constant value. If you use that name somewhere, it's going to shadow the WED that you have. You create a global variable for it. It's like you create a global constant called WED.
It's basically like a kind of keyword.
Yeah, exactly. It becomes a keyword. And if you don't like it to start from 0, you can always change that. You can actually say Sunday is equal to 1. And now it becomes 1, 2, 3, 4, 5. So it starts from 1. Now if I actually okay, so now if I do it, my code won't change, but the Wednesday is not now 3, it's 4. Because it starts from 1. And you can always change it halfway through. And I would say, and I want Saturday to be 0. Or I want Friday to be 0. Right? Stupid thing I'm doing. But if I do this, then it's got to be Sunday will be 1, Monday 2, 3, 4, 5, and then 0 and 1 again. It keeps adding. So you are setting this value to 0. The next one will be 1. I know it's a stupid example, or
But just out of curiosity, wouldn't that cut out?
yeah, there you go. Now it wouldn't. Happy? Okay. Yeah. Okay. I knew what you wanted to say, but I fixed it. Okay. So it's 1, 2, 3, 4, 5, and Friday becomes 10, and Saturday becomes 12. I could do that. You don't want to do it, but you can. Are you okay with this? So this is the C version of enumeration. But the problem over here, as I told you, so I'm going to say C enum. Now, with C++, this is what you do. You have a good example over here. Where did they put it? We talked about moving and stuff. You know that move stuff. I'm not going to go through it. Shared stuff. We went through it already. Unions, actually enumeration. So that's the enum type that we had. In C++, we scope it. So scoped enumeration, they call it. So you add a class beforehand. And that class does magic. So in here, I'm going to say enum class weekday. So what's the difference now? First difference, Wednesday is undefined now. Why? Because these values are now part of the weekday class.
So you need to call them from.
Scope resolution. So I have to say therefore no conflict. And it's not printable anymore, although you have to actually cast it. Okay, let me just do it like that. So for doing that, because now it's a class, see out, you can actually overload the C out for this. So I can actually say operator, O-stream reference operator. Yeah, I'm not going to waste your time for it. There's an perfect example over here that you see over here. It's putting, so in here I'm saying enum class white, yada, yada. And as you see over here, I'm going to say operator like this. And I'm saying if case color is white, then str is white, then I'm going to print white. Let me write it. In here, I'm going to say operator O-stream reference OSTR and the constant. Now it's better to make it capital because it's a class now. Weekday. Okay. Now in here I can write a switch. I can say over here something like switch. And here I'm going to say based on WD. And I can go one by one. I can go over here. Case is weekday, Sunday. Break. And in here I can say OSDR Sunday. Right? And I can repeat that for all the other stuff. Sunday, Monday, Tuesday, Wednesday, so on and so forth. And in here I'm going to say return OSDR. I'm just going to copy the few to 1, 2, 3, 4, 5, 6, 7. So Sunday. This is Monday. This is Tuesday. I could have used a smaller thing, but hey. Wednesday. Thursday. Friday. Now the good thing about it is, although you have more implementation, obviously, and Saturday. Did I have one extra? So I have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. No, I think I'm good. Okay, so you can do this and print it, and it can print Saturday now. Okay, so and you can test the values and stuff like that. It's not like C that when it prints 4 or 5. You have to implement the requirement for it for whatever operator you have, but still it's a class, so you can do stuff with it. You good? So that's scope. It's a scoped enumeration, or we call it C++ enumeration. It's always like that. It's always more work. Okay? Nothing goes backwards. Okay? And to make things better, you have to do more work. Okay. So that's C++ enumeration. Next thing. Say I have an integer array. Okay, so I have an integer array. You know that I can create a pointer to this. We talked about it last time. I can say integer pointer p set to a. Okay. Now if I say p0, see out p10, what is it going to print now? Oh, garbage. p5. We know that, right? Everything's okay with this? Okay, for all those people looking at their screens, unless you are following me on your screens, you have the screen open over there. Okay, look at here, not your screen, unless you're joined online. Anyways, so yeah, we're okay with this? What can I do? So I can say over here, go to next, and I'll put p in here. So when I say, so let's put it like this. This prints 10, right? What can I do? What should be written in here? Can I do this? Is this good? Anybody have any objection to this? You're looking at the question of your quiz. What is the output of the line 13? And you have different choices over there to tell me. So what's going to get printed? You don't need to execute it. Think about it. Walk through it. Okay, so let's say A is sitting at address 200. You good? So P will have 200 in it as the address of the beginning of the array, right? When I say print target of P is the first one that is 200, 10 is printed, correct? Then it comes out, go to next. P, what's going to get passed into PTR? 200, correct? And it's an integer pointer. You add 1 to an integer pointer, it becomes 204. We talked about it 2 days ago. What's the difference between an unsigned integer and a pointer? When you add 1 to a pointer, size of target will be added to it. Not 1, it becomes 204, which is the address of the next integer, which is 20, right? Perfect. When it comes out, P is, what is the value of P? No, it still remains 200. I passed it by value. Again, we talked about it yesterday. 2 days ago. We said, don't give pointers extra credit. They're just variables. I have an integer pointer. I'm just making a copy. This is a copy of P, 200 in it. Beautiful, it becomes 204. Has nothing to do with P in here. Right? Now, let's say it's not C++. If it's C++, I can make it easy. So when I run this, 3 years later when it runs, it remains 10, right? I can make it easy. I can do something like this in here because it's C++, No, I'm going to say receive the reference of the pointer. Therefore, PTR becomes a new name for P, not a new thing. When I add to PTR, I'm actually adding to P. Therefore, the value will be, 3 years later, 20, right? But what if it was in C and I didn't have reference? If you don't have a reference, going back to OOP345NAA, if I say over here integer val is equal to 20, and now I can say add 1 address of val, and val will be 21. Are we okay with this? Right? That's pointers. Nothing fancy. Actually, IPC 144. You learned this in IPC 144, right? So how did I do that? I wanted to change the value of this thing, so I passed the address of it to. So when I have an integer value, I create an integer pointer. Therefore, P becomes the address of val. And when I add to the target of P, I am actually adding to val because its address is passed. Are we okay with this? We can do the exact same thing to this type. Now, let's go back to the logic that we had before. So what is the type of P, people? Actually, pass the pointer to the lady. Pointer. Pass the microphone there. What is the type of P? I want you to read. Tell it to me in English.
It's pointer.
No, give it to the gentleman over there. What is the type of P? Say it in English. The type of P is, it is an
integer.
No, give it to the person over there. Why did you talk? Do you have the microphone?
Integer
Say
pointer.
integer pointer. It's an integer pointer, correct? Give it to the gentleman over there. So P is an integer pointer, correct? Over here, what is the type of val?
Integer.
Integer. To be able to change its value, the function should receive a
Integer pointer.
pointer. So if I have an integer, I want to change its value, I need to pass an integer pointer, correct? Now give it to the lady over there. Actually, the other lady. She doesn't know. Okay. Now, I'm going to repeat, give you the scenario, and I want you to draw your conclusion out of this. If I want to change the value of an int, I need to receive it with an integer pointer. Int becomes an integer pointer, correct? Int, integer pointer. Now, integer pointer needs an?
Integer pointer?
No. Int needs an integer pointer. Integer pointer needs integer pointer pointer. You got it? I have a type. I need the pointer of that type. I told you last time, don't give them extra credit. This is a type. What is the type?
Integer pointer.
What can hold the address of the type? Integer?
Pointer.
Thank you. So I need to put over here integer pointer. And exactly like the other one, I have to say change the target of that pointer by 1 and pass the address of the pointer to it. Integer pointer. A pointer to a pointer. It's not again, if you modularize your learning system, you will have no problem understanding this. We have a type. To receive its address, I need a type pointer. Now change that type to anything you want. Now, next question. No, no, I don't want to confuse you. Forget it. And that continues. Okay, which means, give me a second. Yeah, you were saying, yeah. So you can have integer pointer pointer. Now if you want to change the value of that one, because you're passing the address, you can have an integer pointer pointer pointer. Or integer pointer 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 pointer. Okay? Think about it as a type. You pass a type, you pass to receive its address, you need a pointer of that type, whatever that type is. That type could be an integer, that type could be an employee, becomes an employee pointer, that type could be an employee pointer, then it becomes an employee pointer pointer. Okay? Remember that. But reference made our life easy. All right? Please.
I get the answer. I was just going to ask what's the difference between integer pointer pointer and PTR. It's integer pointer reference PTR.
Integer pointer reference, it's a new name.
Yeah.
So essentially in C++, I can do this to make my life easier because now it's just a new name for an incoming thing. So this PTR becomes a new name. So either I can do go next over here, or I can do go next over here. The result will be identical.
If we do pointer, right? Because that's the pointer. It's not the value. We can use reference.
Yeah, you can use a reference for it. Yeah, I could have used the reference. Integer pointer pointer reference. Sure, why not? Yeah, it's a type. Again, modularize it. But it has 2 asterisks now. Who cares? The name is now integer star star. That's it. Don't give pointers extra credit. They're just types, for heaven's sake. Okay? It's like, okay. So it's like I have a house. Okay? That house has an address, right? So I actually write the address of an envelope. I put the envelope on that table. I go over there. You tell me, where is the envelope? I say, on that table. What does that mean? That means on that table is a pointer to a pointer because you go to an envelope that is supposed to go to a house. It doesn't matter. They are all the same. They're all types. We're good? We okay? Hopefully. Now, if I to show you, first of all, if I run this, you'll see that it's going to advance both of them because of the, okay. Why is this giving me an error? Possibly incorrect order of operation. Oh, yes. Thank you. See? Possibly because it, what was it? What was the problem, actually? If I do this, what is the difference? I made a mistake, a typo.
Then it's clashing between taking it as the operator on the left and the operator on the right.
First of all, that's not a mistake. What I did over here is exactly the same mistake like this.
Well, I'm not saying it's a mistake. It's an ambiguity.
No, this is an absolute mistake. I'll tell you why.
Okay.
Plus plus is stronger than target of. Therefore, first it will add to the pointer. Then it says, go to its target. For what? I don't have any assignments left.
Basically, it's going to garbage.
Yeah, it goes to that place and does nothing for it with it. It's like, go to that table, you come over here. Now what? And I don't say anything. So, were you crazy while you're sitting here? It's the same thing over there. That's why it says possible. It's not a syntax error. It's just a useless thing to do. Okay? But when you do like this, now you're saying, I want the target to happen first, which means go to PTR first, now add 1. So target of PTR, which is a pointer, will be added by 1. And here, PTR is a pointer already. Therefore, it's added by 1. Now, so we good with this? Well, I don't want to drag it. I wanted to show you another example for it, but that's good enough. So let's say I want to create a cout type of thing just to debug stuff. Okay? So I want, instead of, like, I want to print the content of things as the program runs, and I want to be able to turn it on and off. So I want something that's like cout, separate by itself, that I can print into. And because it's another object, is not cout, I can simply mute it. So the messages are not printed anymore. And then I can unmute it. Now it's going to show the debugging statements for me. If I want to create something like that, I would need to have something like this. So first of all, this is a class I'm creating, and I just want this class to be used like cout, as I said, right? So I don't want to create another instance out of it. First of all, it's an anonymous class. It doesn't have any name. It's a nameless class. So I'm going to create class, whatever, and I'm going to call the instance tracer. So tracer is going to be like cout. I print something into it, and it prints it for me. Okay? So to be able to turn it on and off, I'm going to create a Boolean over here, and I'm going to say trace, which means if trace is true, I'll print. If not, I'll ignore the print request. You okay with this? So what do I need to do? To make it work like cout, I need to overload operator. I need to overload operator this, right? Okay.
But you don't need to pass a reference like usually.
Oh, give me a second. Give me a second. Pass a reference to what? To cout? No, this is cout. This is cout. I'm going to use cout inside of it. There is no need for cout to be passed to it. Okay, but I want to explain something important. So now in here, I'm going to say, first, I want to overload something that prints a message. So character pointer constant. Any message, like you want to show a content of a variable or something, you want to put a label for it, right? So in here, I'm going to say, obviously, I'm going to say if mtrace, right? If mtrace is on, print it. Now, how do I print it? I'll go cout message or nothing, in case somebody's troubled enough to actually send an empty thing. I don't want it to fail on me, right? But for this to work like cout, I have to send reference of itself out. Let me show you another. The reason I didn't put a return statement over here for you is to show, to come up with a thing that what the heck we can call it. Give me 2 seconds. So if I want to actually write, for example, I want to print different types, I'm going to create different types of things. So I'm going to create something that prints an integer, right? Then I'm going to create something that prints a double, and so on and so forth, right? But in here, for this thing to work, and I be able to say something, so instead of printing this message, I want to be able to say this. Tracer value of P is target of P. Okay? And say I want to go to new line. I'm going to just go. I want to do this. Okay? I want to do this. So if I want to do this, what happens? This combination, I have the insertion operator. That's good. At right side, I have a message. That's good. At left side, I have the tracer. That's good. Now, this will happen, but after it's done, it should leave an instance of tracer for the next one, right? So the return value of this operator should be the tracer itself, correct? So the next one can get printed, and next one, and next one, and next one. So in here, I should return this, correct? Which means print it, and return the reference of tracer back. The problem is that I don't have a damn name for it. What do I write for the return statement of operator? You know the answer. Thank you. 1% for midterm. So all you need to do over here, and that's why we have auto. You don't need to know the type's name. Okay? By the way, those who receive these percentages will not receive another one unless 2 other people win it. So you're gone. You don't need to answer any questions anymore. Now we've got to go. So now for these, I can actually go return this. And this one, I can go return this, right? And obviously, I need to make it to trace or not trace, correct? So I'm going to write something like auto trace on. No, I'm not going to do that. I'm going to say trace Boolean on. Okay? And in here, I'm going to say Boolean on off. And in here, I'm going to say mtrace is set to on off and return this again. Okay, so now I can turn it on and off. So now I can actually do the trace thingy over here. Why is it giving me an error in here? Did I remove that? Shoot, I removed the, anyways, forget it. Yeah, so now, I can do this. If I run this, it's just going to show the 10. But if I actually set the tracer to on, trace, true. We could have an enumeration up there too. So we can actually have an enumeration for trace on and trace off. You know that, right? So now that the trace is true, it's going to say value of P is 10, and then it shows. So you can turn it on and off. So you can use this trace all over your program and do your debugging, and when it's done, you simply turn it off, and then it's done. You good? So that's a good demonstration for the auto thing. Are you okay? All right. Yes?
Since we had a reference to auto for the trace method, call it as is without anything.
This one you're talking about? I did call it as is. What's that? Oh, you.
Without the object.
Are you kidding me? Trace belongs to, this trace belongs to the tracer object. An object is of type, it's too long for me to read, this. It belongs into that one. Although the thing is nameless, the class is nameless. Oh, we can't, right? Should I take that 0.5%? I'm joking. You're good. You're good. All right. What the heck is this? Where did this come from? Dictation? No? Okay. That's interesting. Okay. People at home, you can still hear me, right? Nobody sleep, hopefully?
Yep. You're
Okay.
good.
Thank you. All right. All right. So now EFGH. In here, I'm going to say use of auto. What is the next thing I need to talk about? Ooh. Yeah. So for that, I need to, you know what? It's 37. We have there 3:15, right? Class. Next class starts at 15 or 20. The class starts at 20, right? So we end at 15. It's good. So let's take 5 minutes break. I'm going to prepare something, and then we'll continue, okay? So 5 minutes break. Please remind me to resume recording. Zoom and resume recording over there. Yes. People at home, are we there?
Yep.
All right. So we are now on inheritance and inclusion, stuff like that. It says specializing operation, dynamic, yada, yada, optional for 3, 4, 5. No, study it. These are important stuff you need to know. Please go through them, everything that you see, and come with questions the next day. I'll go through a few things, and I'll go through everything in detail and tell you what is not going to come on test. Okay? So read it anyways, come with questions, and parts that I see really is not needed, I'm going to say this part, you're not going to have it on the test. Okay, that's clear for everyone? Give me a thumb up at home if it's clear for you. You can do it. Come on. All right. Okay. Goody. Few people are missing. Aaron and Samika are sleeping, which is okay. Let's continue. So we talked about inclusion polymorphism. Anybody remembers what inclusion polymorphism was? Like, you remember? You remember what inclusion polymorphism was?
The various way to do one thing.
Yeah, but inclusion version of it. Polymorphism, yes, it do its few doing the same thing in different ways, but inclusion. So we had coercion, that was casting. We had overloading, that was overloading. We had parametric, that was templates, and we had inclusion, that was. Yeah, with the derived classes. But what in derived classes? Yeah, derived classes are inheritance. But inclusion polymorphism happened when you had inheritance, and in your inheritance you had
Virtual functions.
What did you say? Okay, virtual methods. I didn't hear what you said. Virtual methods, yes. So virtual methods. So let's go through it and see what happens, and I'm going to come up with a few things. So I created over here, this example is very similar to what you have in your notes. So I created an interface over here. What is an interface? What is an interface?
An abstract class?
It's not an abstract class. It is an abstract class, but every interface is an abstract class. But an abstract class is not always an interface. An interface is?
Well, going by general definition, it's going to be something that you interact with in order to interact with something that you don't have access with.
Okay, that's when you're doing art. I'm talking about.
Not necessarily. For example, that also works with cells.
No. In C++, what is an interface? Don't beat around the bush.
It's a middleman function that allows you to have access to what is private. No?
No, that's privacy.
Out.
Anyone? No. Actually, a class with virtual functions, a class with a class with virtual. So wait. Why am I not doing this? I just forgot that I have this beautiful tool over here because I'm just torturing people who are here, and we have lots of people sitting at home doing nothing. So, what is an interface? Yame? Are you with us? No? Kian, what is an interface?
I'm going to be honest, I don't know.
No, that's good. At least I heard something. Perfect. So now Danielle is going to help you. Danielle?
It's a class with at least one pure virtual method.
That's not an interface. That's an abstract-based class. An interface has another difference. That is Parth.
That had at least one pure virtual function.
That's exactly what Daniel said was wrong. That's an abstract-based class. An interface is, oh, you may again. Aaron, you know? Anybody?
I'm here.
Oh yeah, go ahead. Yame. So what is an interface?
It's I think it's a abstract class or object that provide a method to implement.
Yeah, you're giving me the specifications of an abstract based class. Okay, thank you. Thank you, everyone. Thank you, everyone. Why is it not closing?
Can I answer? I know.
Yeah, go ahead.
It has only pure virtual.
Only pure virtual functions. Thank you. An abstract-based class has only pure virtual functions and nothing but pure virtual functions. Everything is pure about it. An interface, and that's an interface. People, please remember. Anyways, it's very important, especially if you go to GPU programming and stuff for next thing. So, anyways, so abstract-based class. So interfaces have pure. So this shape over here is an interface. So in my design, a shape has an area. You can compare it with another shape to see if they are the same identical shapes. You can display a shape, and obviously, always we're going to have a pure we have a virtual destructor that is defaulted if we don't have a destructor. So any class that doesn't need a destructor, you have to create a virtual one that is defaulted. That's the rule. So we do not have a class without a destructor. It's impossible. You must have one. Otherwise, you might have memory leak. Okay? So that's you have to do. We don't need a destructor because there's no dynamic memory allocation, but because inheritance is involved, you create a virtual destructor that is defaulted. Destructors cannot be pure virtual. It doesn't work that way because anything needs to be destroyed. You cannot not have a destructor. You can just default it. Okay? So that's that. And then out of shape, I create a circle. A circle knows what is the area. A circle can compare itself with another shape, and it can display itself. And we have the exact same thing with a square. And square knows what its area, can compare itself and display itself, and I can go through all those things. So a circle says my area is this. A square says my area is this. A square says I can check myself with another shape because shape says compare me with another shape. When you pass a shape to a square, first it needs to know if that's indeed a square. That's when we do a dynamic cast, OOP345NAA. We upcast the shape to a square. If that upcast is successful, square will have the address of the shape. Otherwise, it will be null. So that upcast, by upcasting the shape into the type I need, if the pointer is not null, it means that shape was actually a square. If that shape was a circle, the result would have been null. So I check to see if it's null or not. If it's not null, then I'll check the absolute value between the two sides. If it's below that value, they're the same. If it's not, I return false. And I do the same thing with a circle. So in a circle, I will say, get the shape. If I upcast it with dynamic cast to a circle. If it fails, it's not a circle. So they're not the same. If it doesn't fail, check the radius. If the difference is between such, they are the same. If not, so on and so forth. Are we okay down to this point? We're all okay? All right. Printing it is simple. I just print it, okay? Because the printout was overloaded in the abstract, in the interface. So although that is an interface, but nothing prevents me to actually implement what display is supposed to do. So in here, I'm going to say OStream receives an OSTR, receives a shape, and displays it. Although display was a pure virtual function, but it's going to hopefully be implemented by the children of shape, which it is. So a circle knows how to display itself. Because of that, it will be insertable in OStream, and square can display itself, and that's the same. Are we okay down to this point? All right. That's OOP345 down to this point, okay? Now we come over here. So in display shape, I'm going to say, give me a shape. If the shape exists, show it to me. And this goes to the overload of the shape and calls the proper method because of the inclusion polymorphism. The proper version of display is called. Otherwise, it's going to say, hey, this is a null pointer. Make shape. Make shape returns a shape. Ask the user what you want to create. Based on what user requires, it creates the object, holds it in a shape pointer. So when make shape returns a shape, the recipient of make shape doesn't know what it is. It knows it's a shape. It could be any of those. Are we okay with this? So depending on the user's. All right. Now the problem is that, so in here, I can say make shape. I can say this is the first, so they are the same or they are different. I can display the shapes one by one. There is no problem. I pass the shape. Everything is done properly, okay? The problem is that what happens if I ever need to copy the shape? I want to write a function that receives a shape and copies it, right? If I want to do that, so this function copies a shape into another one. So I have a shape pointer, and I have a shape somewhere. I want to make a copy of that one and put it in this one. I have two copies of the same thing, dynamic. If I pass the shape, how do I know which one to instantiate? I can do upcasting and see if it's null or not. But what if I have 500 different shapes? Then this is going to be a switch of 500 things. How can I do that? The best way of doing it is to ask whoever is building it to create a, actually I think it's right here. Each object must be able to clone itself. Okay? Now all I need to do is to go to my, say, circle, and I just, where's the shape? So this is what we have. I put that one in circle. Now, in here, all I need to do is to say return new circle of me. Right? Each one knows how to clone itself. I use the exact same thing that I use for virtuality, and I call the proper thing. And this is a very common thing that you will see many classes come. It's a standard thing that we do. That's what clone methods do. So if any standard template library, anything you have, it has a clone method, that's what it's for. It copies itself so you don't have to go jump through hoops to do it. So now in here, I'm going to go and do the exact same thing. So in where is it? I'm in Square, right? Yeah. So in Square, I'm going to do the same thing. And in here, I'm going to say return new Square copy of this. Okay? And now I can simply, in my main, where's my main? In here, instead of new, I can simply say s.clone. Done. Okay? I know I could just call the clone. I don't need to write the copy anymore. But I needed to write that to tell you, because this is redundant, because you just call that function. I have a function that calls another function, just call that one instead, right? But I'm just showing you. So now that's possible. I can actually copy things properly without writing any kind of logic behind it to identify what it is. And therefore, my main can now do things like this. I can actually clone, and I can delete, and everything then can work with this hierarchy of mine. So at any moment you have a hierarchy that is created out of an abstract base class, make sure you add a clone to it so copying is possible. We good? Are we okay?
The 5,000 shapes that you mentioned.
Oh, yeah. And this is one line thing. They're not doing anything difficult. They just make a copy of themselves and return. Yeah. Always, you always do the dirty work so the person who's using your class doesn't have to. You have to always make things easier for the next programmer. It is always possible to have a way to go around bad design. If somebody does a bad design for you, there is always a way to. Okay? But if you have good design, life is beautiful for everyone. Okay? Questions down to this point? All right. So as an introduction to what we are actually, no, it's 309. Let me just see if I can do this. So I'm going to save this main as EHI. I'm going to call it clone.cpp. So you know that's what it is. I should have run it first. Let me see if it actually runs or I have an error in it. Fingers crossed, it works. Okay. Oh, really? There you go. Okay, it works. All right, so close all tabs. Now we don't have enough time. So the next day you're coming in, we'll talk about templates. Okay? We'll talk about templates, go through it, understand what it is. If you have access to your OOP345 stuff, go look at the recordings of templates in OOP345. It helps. It's almost the same lecture. Okay? Remember I told you when I'm teaching you this, it's not going to be in a test, but it's good to know for 345. That's what it is. So we understand what templates are when we come the next day, and then after that, we can actually start using standard template library when we know how templates work. Questions? Suggestions?
Do you remember in OOP345 on which sessions we talked about templates?
Probably it's in the playlist. Just go to YouTube and type, or I don't know, it's at the big end of the semester. Yeah.
After midterm.
Oh, yes, end of the semester. Like maybe last 2 weeks, 3 weeks of the semester. It's very end of the semester. Yeah, but if you just Google for a template C++, probably the session is going to come up.
Oh, that's
Yeah.
a good idea. I was just thinking to go to the...
Yeah, you can go to archives too. So just to show you very quickly, you can go to archives of OOP345. It says FARDA's notes, the FARD notes archive. If you go over there and probably go somewhere 2247. If you clone it, you can simply look for it, but I have no idea. Is this 244? I went 345. 244? I don't know. It's one of these templates. When do we have? No, this is inheritance. Anyways, Google it and find it. All right. Any other question? Suggestion? All right. Have yourself a beautiful day, people. I'll see you soon. So the next day you are coming in, it's lecture. And the question, if you want to have, so I'm going to have the question open for everyone. So think about if you like to have small concept tests, like couple before the test that is coming, and cover the concept stuff that we have, so you don't have to do it during the test, so you have more time for your programming. Let me know of that. Have a beautiful day, everyone.